So, see how it says here, compound inverse questions. Let it happen. See, this is not an equation. I'm not solving anything here. I'm evaluating something. I'm going to figure out what the numerical answer is that they want from this. But this is the part that I'm going to let happen. See, I know how to take the sine of something. I can take the sine of an angle if they gave me an angle. But they didn't. They gave me arc cosine 1/4. Well, they did give me an angle, but it's written in cosine inverse form. So here's how we do this. We do something called substitution. I'm going to assume this thing is an angle. It is some angle. I don't know the angle yet, but I write it like this mathematically. I say let theta equal arc cosine. So I'm just going to rewrite it like this. Let theta equal arc cosine of 1/4. Well, what does that do for me? It gives me something I can work with. I'm going to say, hey, cosine of that angle theta, cosine of that angle theta. You see where I'm going with this? What it's going to give me is cosine of theta equals 1/4. Hey, cosine of theta equals 1/4. You happen to be a positive 1/4. So if I'm evaluating a cosine inverse function, I'm going to draw myself a triangle. Come on. In quadrant. Which one? 1 or 2? Which one do I use for cosine? I use 1 because it's a positive. So I'm drawing myself a reference triangle. I'm going to call this thing theta. And I'm going to say cosine of theta equals 1/4. Whoa. Dang it, that's happened to me before. I got to get out and then go back in. Okay. What does that do for me? Well, it means I have adjacent over hypotenuse. And then I got to figure out what the missing piece is. But I just do Pythagorean theorem. Long story short, this guy turns out to be rad 15. Now, what do I do with that? Well, I used, first, I let this equal that. I got it to a situation where I could draw a reference triangle. I did, and now I go back to the original. They want me to find the sine of some angle. Oh, the sine of theta. Well, I already know what theta is. So the sine of that thing is rad 15 over 4. The answer in the back of the book is rad 15 over 4. They're going to have me find these numerical answers. So, don't get spooked by this section. It's a new thing. In math, we do this let something equal something a lot. Let's look at another one. Don't panic. This one says, find the secant of sine inverse of negative 1/5. So here's what I'm going to do. I am going to let theta equal the sine inverse of negative 1/5. That's what I'm going to do. So this part here, I'm going to just call it theta. So when I finally get to the end of this problem, my answer is going to be whatever the secant of that theta angle is. This is my actual prize. This is what I'm shooting for. This will be my answer when I get there. But how do I get there? Well, I take this statement that I just created, I let theta equal that, and I go with it. So I go, hey, if I take the sine of theta, that's the same as taking the sine of sine inverse of negative 1/5. Then I get sine theta, sine theta equals negative 1/5. And remember, I'm dealing with a sine inverse. So where am I supposed to draw a reference triangle that's negative for this? I'm supposed to be in which quadrant? Quadrant 4. That's from page 253. That stuff's still the same. So I would say this is the angle they're going to have me use for my reference. And I'd say opposite over hypotenuse. And then I'm using Pythagorean theorem, so it's going to be a squared plus b squared equals c squared. So this missing chunk of junk over here turns out to be square root of 24, but of course I would never do that. I would simplify the rad, and I would say 2 rad 6 is what they want me to use. So I say 2 rad 6 is what I'm going to use there. And away we go. What do they really want from me? They want to know the secant of that angle theta. They want to know the secant of that angle. So once again, I go, okay, the secant of theta. Well, my brain doesn't think in terms of secant, but it does think in terms of cosine. And if I found the cosine of that angle, it would be adjacent over hypotenuse. I'd say 2 rad 6 over 5. But I'm not finding that. I'm finding its reciprocal. So the answer is 5 over 2 rad 6. But then I say that's not the answer in the back of the book because they multiplied by rad 6, top and bottom. And I get 5 rad 6 over 2 times rad 6, that's 12. Why did I write a 12 there? I just saw that. I can't believe I did that. I was thinking ahead. So I get 5 rad 6 over 12. Not the prettiest answer, but that's the answer you would find in the back of the book. So your answer, and you get it. This is all numerical. All your answers are going to be numerical. And just a reminder, exact values are what they're looking for, which means never a decimal. Here we go. Let's look at another example, but this one is sneaky, I got to tell you. But this is a sneaky double angle in disguise. See, normally I would start off and say, oh, let's just call this whole thing right here theta. But this guy is what makes it sneaky. See, there's that 2 there. So what I'm going to end up with is this. See, I'm going to rewrite this problem. So it says tangent 2 cosine inverse 1/4. That's what I'm going to do. Then I'm going to call this thing theta, which is this guy. So the tangent of 2 theta, I don't know what it is, but when I get to the end, that's going to be my answer. It's a sneaky double angle in disguise. I have to factor out this 2, which means I just have to bump over my parentheses. Well, let's begin. I am going to write a statement that says theta equals cosine inverse 1/4. I'm going to then go cosine on this side, cosine on that side, which means the cosine of this angle theta is going to equal 1/4. And it's a positive 1/4. So for cosine, I'm supposed to look in quadrant 1 for that. So I draw my reference triangle. We do a lot of this in trig. You draw a lot of triangles. And that's my theta, and I'd say adjacent over over hypotenuse, so katoa. If I do the Pythagorean theorem, I'm going to find out that this guy is rad 15. That's what he is. And now I'm supposed to say tangent 2 theta of that answer. Well, what the heck is that? Oh, that means I have to do the double angle form of this. I have to say, oh, that's when you do 2 times the tangent of theta over 1 minus tangent squared theta. Well, I can find the tangent of theta. It's not too tough. It's not a brain buster. What's the tangent of theta? I use my reference triangle. I go to say the tangent of theta equals rad 15. I'm going to now plug that in to my formula. I'm going to say 2 times not tangent, but times rad 15 over 1 minus tangent squared theta, but rad 15 squared. What do I have? 2 rad 15 over 1 minus, well, rad 15 squared is just that. So what do I have? I have 2 rad 15 over 1 minus 15, that's negative 14. I can reduce, and my answer turns out to be rad 15 over 7, but it's negative. And if you look in the back of the book, that is the exact value answer you would see. Now, if you already have your book open to page 260, you should be able to recognize that some of these are double angles in disguise. I asked you guys to do the odds. So number 83, that is a double angle problem in disguise. Number 85, double angle in disguise. Number 87, double angle in disguise. Let's see, well, you're doing the odds, so that would do it. But I'm looking at the problems on the page there. Look at problem 90, just for kicks. We're going to do this real quick because I don't want anybody to get stuck. Here's number 90. It says this. Well, I know you're not doing the evens, but it says cosecant times cosecant inverse of rad 2. All right, you ready for this? This is the cosecant of cosecant inverse. Bam, I'm done. I don't have to draw a reference triangle or anything like that. Don't overlook the obvious. This is what I call a duh question, because the answer is right in front of your face. You take the composite of this, and you just get whatever x is. So if they said, what is the cosecant of cosecant inverse of rad 5, I would say the answer is rad 5. If they said, what is the cotangent of cotangent inverse of, 2, I would say the answer is 2. Some of these, don't let them fool you. Let's go back to the top. This was the secant of a sine, so I don't get that luxury. Wait, to the top. This is a sine of a cosine inverse. I don't get the luxury I just had there. Same thing with this guy. No. This guy's a double angle in disguise, but don't blow it. If they give you the obvious, you get to just run right through the problem and get to the end. We got one more example to do, so here we go. This one is a sneaky cosine A plus B in disguise. This is a couscous. Well, what do I do about this one? Because there's two chunks. See this chunk and this chunk? I'm going to call this guy A. I'll let that happen. I'm going to call this guy B. I'm going to let that happen. So, how am I going to answer this question? Eventually, I'm going to do a cosine A plus B expansion. But how am I going to start it off? I'm going to say let A equal sine inverse of 3/5. And I'm going to say let B equal the cosine inverse of 5/13. Let's do one at a time. I'm going to do the sine one first. So I'm going to take the sine of this. I'm going to take the sine of this, right? So I get the sine of angle A is equal to 3/5. I'm going to draw myself a triangle because that's what I do. I'm in quadrant 1 because that thing's positive. I'm going to say, hey, A, opposite over hypotenuse, 3, 4, 5 right triangle, bam, that's a 4. I now have a reference triangle for angle A. I'm going to go over here and do the same thing. I'm going to do the cosine of this. I'm going to do the cosine of that. I'm going to then have a statement that says cosine of B is equal to 5/13, which also puts me in what quadrant? Because it's a positive 5/13. Puts me in quadrant 1. But this is my reference angle B, not A. So I'd say, oh, cosine, adjacent over hypotenuse. This is a 5, 12, 13 right triangle. So I lucked out there. They gave me some pretty stuff. But what am I going to do? I'm going to take this and I'm going to couscous it. So I'm going to say the cosine of A plus B is what they actually want from me. That's what they actually want from me because it was in disguise. Cosine of A plus B. Well, we have an angle A, we have an angle B. We can go grab our stuff and complete this problem. Remember, cosine of A plus B just equals couscous. Cosine A, cosine B, minus, because sine A, sine B. Well, let's fill in the blanks we already know. They told me the sine of A. That's 3/5. What else did they tell me? The cosine of B. They already told me that. That's 5/13. So let's get the cosine of A. Let's fill in the blanks here. Cosine of A would be adjacent over hypotenuse minus, what's the sine of B? I have to go grab that. That looks like it's going to be opposite over hypotenuse. And I don't want to cross cancel. I don't want to jump the gun on anything because, look, if I multiply 5 and 13 on the bottom of this problem, I'm going to get 65. And on the top, 4 times 5, that's 20. Take away, on the bottom, I already have a common denominator if I leave it alone, 65. And then 3 times 12 is 36. So when you check the answer in the back, it's going to say your answer is -16/65. And that